So thank you very much, Ian, for giving us a quick open. And I just want to take a few minutes to review a little bit about the project for those of you who are new to the project, and also talk a little bit about CDR, just so we set the table for a lot of the sessions today and save a bit of time there. So the project aims to assess the potential of carbon dioxide removal to meet Canada's 2050 net zero goal and identify policy options that could enable sustainable, equitable, and rapid deployment of CDR in appropriate contexts, right? So it's sort of a mouthful, but it's clearly from this, I hope you'll understand, an interdisciplinary project. And we were able to do this with the support of Environment and Climate Change Canada, who provided initially a $4.2 million award for 5 years. We're about 3 years through that and have about 2 years remaining. And we were very fortunate to receive an additional $1.8 million from Natural Resources Canada that allowed us to expand some of our initial scope into some experimental work. And so this is a joint effort. Something of this magnitude is very difficult to pull off on one's own. And of course, this is an example of that. We have around 25 faculty and staff across 4 different universities. Obviously here, the University of Calgary. We have people from the University of Alberta, Simon Fraser University, the University of Toronto. And at those universities, we have nearly 30 graduate students, postdocs, and summer students. Today's meeting has been organized with part of the expertise of the Pembina Institute, who really focus on knowledge mobilization, and we've worked a bit with CanMet Energy as well. So we have a big effort going on of this. And we're so interested in putting so much time and work into this because every ton of CO2 we emit adds to global warming. And that's the problem that we have, and the problem that CDR is trying to help us solve. So this map, or this figure, as many of you have seen from the 6th assessment report of the IPCC, is showing us on the vertical axis the temperature change since 1850. So we started at 0, it was pre-industrial. And then on the bottom axis, we have cumulative emissions since 1850. And if you stand back and look at that, there's pretty much a straight line. There's a very tight relationship between the amount of carbon dioxide we emit cumulatively and the global temperature rise that we are seeing, right? And we see both historical and trends into the future. And what this means is that to limit our climate change, right, limit temperature rise to any level, we have to limit our cumulative emissions. So this isn't just about making our emissions rate very small every year, it's about getting to 0 or even below 0. And so if we want to hit a 1.5 degree target, we have less than 235 billion tons of carbon dioxide that remain for us to emit. And that's great, right? Sounds like a huge number. The only problem is we emit 40 billion tons a year. So that's a relatively short time frame to hit a 1.5 degree target. And even if you say, well, that's all pie in the sky, any target, say a 2 degree target, still gives us a finite runway to hit net zero on our emissions. And that highlights the 2 roles that CDR possibly has. And so we need these negative emissions, and negative emissions is what CDR can deliver, right? It's going to pull carbon dioxide out of the atmosphere for 2 reasons. As this gray wedge shows, if we follow an emissions reduction trajectory, at some point we are going to get our rate of emissions very low, which will be great, right, if we can strive to do that. But we'll still have things which might be difficult to emit, like emissions from agriculture or manufacture of cement. And so ultimately, we need these negative emissions technologies to generate this blue wedge below 0 that will offset some of these positive ongoing emissions. And also in the blue crosshatched area, you see we actually might drive emissions below 0, and that would be because we've just gone too slow. Right? Too slow to reduce our emissions, and we might overshoot our budgets. And so carbon dioxide removal is certainly a feature of all Paris consistent scenarios. So in a data set of about 455 scenarios from the State of Carbon Dioxide Removal Report, they found that the median deployment was around 6 to 10 billion tons of CDR per year in 2050. Right? So that's something like a quarter almost of our emissions today. And the cumulative removal, by the time we hit that net zero, so by the time that line crosses 0, was something like 200 to 360 billion tons of carbon dioxide. And so if we're going to get to these levels, we need more than just technology. As Ian said, we need policy and we need society to be on board, right, with the use of these sorts of technologies. And we can do this through many different ways. We can do it through things that on the left-hand side of the figure, and the gray boxes at the top, you can see things like afforestation and reforestation, soil carbon sequestration, biochar. These things are known as conventional pathways or natural pathways, depending on your preferred language. And they work well. We're doing that today, right? We grow trees, we have standing biomass, and we put biochar and things into the soil. Then we have more technology-enabled pathways, such as bioenergy with carbon capture and storage, direct air capture and storage, and enhanced weathering and ocean alkalinity modification. And those are the technology pathways that this project's focusing on. And it's not because we don't like the other ones, the natural or conventional pathways, it's because the expertise of the group lies in these technical pathways. And so that's where we're focusing. So if we think about those, we have all kinds of questions to answer. Because I think right now we're placing some bets, big bets possibly in these scenarios on things we don't totally understand. Some of those questions might be, what are the technical constraints on doing CDR in Canada? And do these technical constraints even matter? Maybe the social constraints are the things that will bind. How do the technology performance vary from place to place? Can we expect these technologies to get radically more efficient and cheaper, like many technologies, but not all? What does the public know about CDR in general? What do they know from place to place? What do laws and regulations say about CDR? Are they supportive? Can they encourage CDR? And if we do a lot of CDR either in one place or globally, what is the environmental impact of that? And so these are the sorts of questions that we're trying to understand and answer through a transdisciplinary or interdisciplinary lens here in our project. And we'll be talking about today. So I'm going to hand things off to Carson now. And Carson's been the agenda ringleader who's made sure and herded the cats to show up. So I'll pass it to Carson. He's going to give us a quick overview of what we're doing today and then move us into other sessions.